Hopefully this is the final part of this review. Apologize for part 3 being shortened. Had a weird thing where we had to evacuate, but whatever. Let's go. Number 5, vectors. So, this says let vector m be equal to 3i minus 7j. So really, it's 3 times I, which is 3, 0, and then minus, so we'll put a minus there, 7 times j, j is 0, 1, distribute, we get 0, 7. So that's just 3 minus 0, which is 3, and then 0 minus 7, which is negative 7. Now what I taught in my classes is that this is kind of like, you just cheat. 3, negative 7, and you can skip all that if you want. But I had to show the work. Sketch the vector. Well, this means, remember, these little pointy guys that look like parentheses means component form. Now when you see that, you should know it's a spinner that originates from the origin. It's all about the spinner, remember that? So 3, negative 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, had to squeeze that in there. And there it is. So that's your vector, 3i minus 7j. Write the vector in component form. We did it. What's the direction of the vector? Well, remember, direction is another way of saying how far did you have to spin your spinner to get there. So we got to figure out that degree measure. Well, it's 90 plus 90 plus 90 plus that little smidge, but we got to figure it out a little differently. We know my drawing's a little off, so forgive me, but this is 3, negative 7, and so yes, we could go a squared plus b squared equals c squared, but what I'm going to do is realize that this little guy, I'm going to use fishy there, alpha, I know that this is my opposite side, and I know that is my adjacent. So I'm going to go tangent of little fishy equals opposite over adjacent. Get out my calculator. Now just so you know, when you're doing these problems, you should always just check, make sure you know whether you're in degree or radians. Well, I'm going to go second, tangent, use the negative button, not the minus button. That's kind of important. The negative button's right there. Calculator gets kind of weird if you don't. So negative 7 divided by 3. Hit enter, and negative 66. So in this case, alpha is negative 66.8. That's what this is. But the direction is how far you have to spin your spinner to get there. So that would be 360 minus 66.8. So I'm going to do this in a weird way, plus 360. So I know it's 293.2. So 293.2. Now if somebody actually put negative 66.8, I have a hard time saying you're wrong, because that's where you had to spin your spinner down. But the direction angle is normally a positive spin, and normally they give you these little they squeeze you into that parameter, which means only positive answers, por favor. But technically that's not wrong, you're just not following an instruction, so it's kind of splitting hairs. Write the component form of the unit vector. Now that means the radius equals 1, or the hypotenuse equals 1, in the same direction as that vector. So really what we're doing is they're painting us a different picture, and they're saying, okay, so if this is, let me try to draw this with some accuracy, 1 in the same direction as this, we got to find the component form. So that means you're not done until you find the new x and the new y. And of this situation where that's a 1. Now my drawing's way off. Well, there's a formula, and the formula is the component vector is A all over the magnitude of the vector, comma, B all over the magnitude of the vector. And this is your unit vector in component form formula. I don't know if I said that properly a little earlier. But, so, if we actually have to find the magnitude of the vector, that's telling us we have to find the length of the hypotenuse. So we got to go a squared plus b squared equals c squared. That's 9 plus 49 equals c squared. It's 58 equals c squared. So we take the square root, can't be negative. So that's what we're going to put there. And the component form of a unit vector formula right here is going to take care of us. So A is actually our x value, B is actually our y value. So that's 3 over the square root of 58, comma, negative 7 all over the square root of 58. And they're not worried about getting the radical out of the denominator in these. And if you wanted to prove it to yourself, if you were just that person, you're like, man, that doesn't make sense. Well, every picture tells a story. If this is true, and again, this is the same drawing, just shrunk. And it just doesn't look shrunk. So I would square this, and I'd get 9 over 58. I'd square that. I'd get 49 over 58 equals 1, because that's 1 squared. And we'd go, hey, I guess that worked. So if there was any doubt that this formula works, there you go. So new problem. Let vector u be 6. Remember, these little pointy things means the spinner starts here. That's the end point. That's what they're trying to tell you. So 6, negative 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. It's right there. This one's going to be a little easier than the last one because that's 6. That's negative 8. We have a 6, 8, 10, which is built off of a 3, 4, 5 family. You just multiply them all by 2. 6, 8, 10. If you don't know your families, you can use Pythagorean theorem. You'll still get 10. So what's the magnitude? The magnitude is the length of your spinner, radius, hypotenuse. So that's 10. Direction, again, is asking you to find how far you had to spin your spinner in a positive direction to get here. So I'm going to use fishy, and this time, just for kicks and giggles, I'm going to use adjacent and hypotenuse just to change it up. Cosine of that angle is adjacent over hypotenuse. And I'm kind of glad I did this. This problem actually just gave us negative 66.8, which matches what we're looking at. This is going to be different. Your calculator notices that this is positive, and remember, all students take calc. Your calculator knows that all things are positive and cosine is positive, but it's probably just going to give you the answer to here, and we're going to have to make an adjustment. Not here, not here. So we go, here we go. Second cosine, I'm going to reduce that to 3/5 or 0.6. It gives us 53.13. So it's telling you if you spin your spinner up 53.1 or 13, you can have a triangle where your adjacent side is 6 and your hypotenuse is 10. The thing is, we know that cosine can be positive here also, so we're just going to have to make the adjustment and say, well, this must be 53.1 as well. And to find how far we spun our spinner to have it stop right here, we got to subtract that from 360. So that'd be 306.9, I think. That's how far you had to spin your spinner. It's called the direction of the vector. Okay, keep going. So if vector A is this, vector B is this, vector C is this, find the component form of the following. This is just the easiest stuff in the world, so don't make a mistake and watch me make a mistake. This is just saying distribute a 4 through the vector. So we'd get negative 8, 16. Low hanging fruit. Gotta love that. A plus C. Well, that means we go this, negative 2 plus 5 is 3. 4 plus negative 3 is 1. All right. B minus C. So it's 1 minus 5, negative 4. 7 minus a negative 3 is positive 10. And if it's written like this, I'd recommend figuring out what that is first. Don't try to do too much in your head. I'd screw something up if I tried to do all this in my head. So 214, I just doubled everything in B, minus triple everything in A. So negative 6, 12. That's a minus. So 2 minus a negative 6 is 8. 14 minus 12 is 2. And that'd be done. Okay, let's keep going. Determine the component form for the following vectors. A vector with magnitude 8, direction angle 210. Let me pause this a second. Alright, so there's the drawing of the situation. Here's 210. Here's our spinner, length 8. Spun at 210. And we go 180 plus 30 gives us that direction angle right there. And we think, okay, what's the component form? Well, we build our triangle, always back to the x, never back to the y. And that's 30, 90, 60. Back to the rules, there's 8. So this has to be 4, but it's negative. And I multiply that by the square root of 3 to get this. And that has to be negative also because it's left and down. So what's the component form? Well, this is my x, that's my y. So that'd be negative 4 square root of 3, negative 4. I've been warning you guys, 30, 60, 90s are going nowhere. Now find a vector with magnitude 3, direction 300. Spin our spinner 300. There's 270 plus 30. If you need to look at that, it's helpful because that tells us this is 60. Here comes our triangle right here. But our magnitude 3 is right here. It's kind of a wonky number, but it doesn't change your rules. This is the hypotenuse, so you take half of it to find this little shorty. So that'd be 3 halves. And you multiply that by the square root of 3 to get this. But it has to be negative. So the component form would be 3 halves, comma, negative 3 square root of 3 all over 2. Done. Okay, number 9, let M, this is a point, that's not a vector, because look at parenthesis, parenthesis, so it's just a point. So there's letter M, and then point N, 5, negative 8, so 5 to the right, down 8, that's letter N, and again, that's a point. It says sketch vector MN. Well, that's kind of easy. We got our points there, so now we're just going to connect. But here's the important thing. The order matters. From M, that makes this X1, Y1, to letter N, Nancy, that makes this X2, Y2. And the reason that's important is because we've got this component form formula here. This is a vector off in space, but in order to make sense of it, to find the magnitude and the direction, we have to convert it to a component form. In other words, this turns it into a spinner. That's the only way you can find the direction angle of a vector. All right. So let's pop this information into here. All it's going to do is slide this point to here, this point down a little bit so that it will look like this. Let's watch the formula do its thing. So x2 is 5 minus x1 is 1, comma. y2 is negative 8 minus y1. Very important to get that order proper. So it's x2 minus y2 is where the vector ends. You got to keep that in mind. Very important. So 4, negative 10. So that means its origin is now, well, its starting place is now the origin, and that's the end point. So 1, 2, 3, 4, and then down 10, there's 8, 9, 10. Picture's not perfect, but there it is. All right, give me a second. All right, I just wanted to get rid of the previous information so that now 4, negative 10, we know that the end point is 4, negative 10. That's the end point. But the component vector tells us that this is 4 to the right, so 1, 2, 3, 4, and then 10 down. Now we can make all sorts of sense of this. What's the magnitude? Well, we got to go a squared plus b squared equals c squared. That's 100 plus 16. So 116 equals c squared, so we go like this. Now, it's kind of confusing because sometimes the book breaks that down, sometimes they don't. One little lesson I was taught way back when is if 4 goes into the last 2 digits of any number, 4 will go into that number. So that could be broken down into 29. So that might be 2 square roots of 29. I don't think that's a huge deal, but there's the magnitude. What's the direction? The direction is how far did you have to spin your spinner in degrees to get there? I'm going to use this trick. I'm going to use tangent of, I don't want to deal with this, so I'm using tangent opposite over adjacent. Remember, sometimes it plunks you in the right quadrant, sometimes it doesn't. So second tangent, negative 10 divided by 4. Negative, so that little alpha is negative 68.2, that's an 8. So that's what this is. But traditionally, you figure out what the positive spin is. So I have to go 360 minus that. And so I'd get approximately 291.8. That looks familiar. Seems like the same answer as before. All right. Last problem of your review. A jet is flying 400 miles on a course 30 degrees east of north. If the jet experiences a crosswind blowing due south at 20, determine the resultant speed and direction of the jet. All right, so I'm going to draw the picture of this, then explain it so I don't bore you to death. Okay, so number 10, here we go. A jet is flying at 400 miles per hour, magnitude, on a course 30 degrees east of north. So we start at north and we tilt it that direction. So north is this way. The plane is right here, 400 miles an hour, so maybe if I draw a plane, that'll help. Look at this guy. There you go. There's the plane. I probably shouldn't have done that, but oh well. There's the airplane. It's going 400 miles an hour. It's in component form. It is blowing 30 degrees. This is 30 degrees east of north. And there's a crosswind, which is a little bit strange, but it's a wind coming due south, right out of the south. That's what that means, 20 miles an hour. So notice this is 400, this is 20. This is way longer than it should be. Should stop right there, but then my triangle wouldn't really be clear. So now that I got my drawing, the question is, what's the resultant speed? Now remember, speed is magnitude. So what we're going to do is I'm going to take a red ink pen and connect the dot. Well, maybe I shouldn't do that yet. So this 30 degree measure is going to be very helpful. I'm going to just throw this is like a geometry problem now. And so that's 90, this is 30. And if I connected the dots right here for just a second, this might help me, it might not. I know that's 90. I know this has to be 60 for all sorts of reasons, and there's just information jumping right off this whole page. So I'm just kind of turning this into a geometry problem. Now that I've done that, now I'm going to connect this. Maybe I should make it not red. But now we've got this triangle that we're going to pull as much information as we can, because what they're really asking us is, what's this guy's length? That's really the speed of the resulting crosswind. So I'm going to kind of peel that off from the page, make it bigger. So it's this, 20. It's this, 400. And if you look right in here, that's 150. So I'm going to put that right there. And then I'm going to connect the dots. And notice what we have. We have 2 sides, 1 angle. We are off to the races. I'm going to put some random letters in here. And now we've got our law of sine, sine of A all over A, sine of B. Give me a second. All right, so there's your law of sine, law of cosine. Now here's the thing. In order to use the law of sine for this, I'd need 2 of the 3 fractions, 3 of the 4 parts. I've got this side of angle C, but no angle. I've got this angle, but no side. I've got this side of angle side A, but no angle A. So that is out. But I picked the one law of cosine that involves angle B because that's the one we have. And now we're just going to realize, wait a minute, all I need to do is find B. And that's in that formula right there. So B squared equals A squared plus C squared minus 2, don't screw up, A C cosine of 150. And now I'm just going to condense things. B squared equals 16 followed by 4 plus 400. This is 800. I don't want to screw this up at the last second. So let me double check. 400 squared. Yes. I know that's 400. 800 times 20. 16,000. So minus 16,000 times cosine of 150. Again, double check your calculator. Negative 0.866. Make sure in degrees. I think I was, because I just checked it. All right, so now we have to be careful. B squared equals, I'm going to multiply this out. That's going to be plus 16,123 times 0.866. I didn't worry about the negatives because 2 negatives make a positive. So I got 660,000 plus 400 plus 13,856. All right, so plus 400 plus 160,000. And I get B squared equals 174,256. Now I got to take the square root. So second square root 1742. This seems too much. 56. Oh, I guess not. So it comes out to approximately 417 point whatever 44 miles per hour. That worked out. That's a crazy math problem. A lot going on there. And one thing, the whole 30 degrees, it starts out like this. A lot of students are going to think, oh, I got to use my 30, 60, 90 rules. Not in this case, because the southern wind built a new triangle, but we needed to figure this out using our right triangle information. And that's the key to this whole problem. That number could be 29, it could be 25, it could be 33.4, so don't jump off and instantly think it's got to be 30, 60, 90s. Well, there you go, guys. That finishes the review. Good luck. See me if you have any questions.